QoS models. If we do not address to some requirements, some limitations which will come with the QoS in a proper structured way, you will be having future difficulties to expand your services. So therefore, we would like to discuss QoS models or successful QoS models in this video section. So you can choose one of this model to introduce QoS which are operating with enterprise level, corporate level, service provider level environment. Best effort QoS model, it is the model where you get no QoS implementation because it treats all network packets in the same way. Emergency voice messages is treated the same way that a digital photographic attachment in the email. So we have benefits as well as drawbacks in best effort model. Scalability is only limited by available bandwidth. No special QoS mechanisms are available, and it is the easiest model to deploy. The drawbacks: there is no guarantee if we have regular bursts in a network, so you will be having a lot of packet drops. No special preferential treatments will be given to packets, so then the critical data can be dropped very easily. When it comes to this integrated services, IntServe delivers the end-to-end QoS that real-time application requires. So explicitly manage network resources to provide QoS to individual flows or streams, sometimes called micro flows. And therefore, during the communication process, you will be getting the priority from source to destination as we expected, as we configured. So therefore, it is connection oriented approach. The edge routers perform the admission control to ensure that the available resources are sufficient in the network. The application requests a specific kind of service from the network before sending data, and then the application informs the network of its traffic profile, about its bandwidth and delay requirements. Then finally, the integrated service uses the resource reservation protocol (RSVP) to signal the QoS needs of an application's traffic in the end-to-end path through the network. If the network devices along the path can reserve the necessary bandwidth, so then the application data will be communicated. If not, the application data will be discarded. Because of this integrated service QoS model, we have end-to-end resource admission control mechanism. Therefore, we can guarantee the quality of the data travel. It is per request policy admission control. So we have micro flow management in the QoS process. Therefore, so you can treat to traffic in a micro level approach. In the other hand, this is not a scalable approach. The larger networks like the internet, flow-based approach may not be the best approach. For the larger implementations, it is preferred to use differentiate service QoS model, which is not an end-to-end QoS model. Host forward traffic to a router, enforces and applies QoS mechanisms on a hop-by-hop basis, uniformly applying global meaning to each traffic class to provide both flexibility and scalability. We don't get end-to-end QoS strategy, so you can prioritize one traffic type in the first hop, and when it goes to the second hop, maybe another traffic will get higher priority than the previous one. So you have this dynamic approach to manage your traffic within the large network implementations. Therefore, you have the flexibility and scalability in differentiate service QoS model. Again, we have benefits and drawbacks. It is highly scalable approach and provides many different levels of quality. But again, it is not providing absolute guarantee for service quality. Time to time, so you will be getting less priority in the middle of the communication. And it requires a set of complex mechanisms because you have to configure it in hop by hop basis. Therefore, the misconfigurations or ill behaviors or bogus behaviors of the network may cause to the quality drops in a network environment.